Alright, this video will go over other types of equations that you'll be asked to solve. Now, one other type of problem that you'll be expected to do is what we call the work rate problems. And here's a hint: if we say that a job can be completed in a certain amount of time, then the rate that it takes to complete that job would just be 1 over time, because we're working on one job and we're trying to see the rate at which it gets done. So, to figure out the amount of work completed, you just take the rate, multiply it by the time. Alright, this example says one printer can do a job twice as fast as another. Working together, both printers can do the job in 2 hours. How long would it take each printer working alone to do the job? Alright, we know the amount of work being done is equal to rate times time. It's working on one job, right? So, the amount of the first printer plus the amount of the second printer is equal to one job. So, what we're going to do here is create an equation to solve. And we're going to use that to figure out how long would it take each printer working individually to do the job. Alright, so the rate, so the amount done by the first printer is equal to its rate times the time, which is 2 hours, plus the amount of the second printer is equal to the rate of the second printer times the time, which is 2 hours. That's equal to 1. Alright, remember, the rate is equal to 1 over the time. So if we let the first printer, if we let that rate be equal to 1 over the time, it'd be 1 over the time times 2, plus, we said the second printer was only half as fast as the first, so it'd be 1 over 2t multiplied by 2. The rate is 1 over 2t for the second because it's half as fast. So if we make the bottom 2t, since the 2's on the bottom, the rate of production would be cut in half. So now if you multiply the 2's together, or the 2's for the time by the rates, you'd have 2 times 1 over 2t. The 2's would cancel out, so you'd have 1 over the time, plus 1 over t times 2 would be 2 over t, and that equals 1. So now if we solve for t, that would give us the time it took the first printer to work. Or that's how long it would take the first printer to complete the job. So 2 over t plus 1 over t would give us 3 over t equals 1. So now if we multiply both sides by t, you have 3 equals 1 times t, which is just t. So that means the shorter printer would take 3 hours, so it's supposed to be 3 hours HRS, and the longer printer, or the slower printer, slower printer, since it's only half as fast, it would take 6 hours. Alright, here's another example. It says 2 chemical plants are polluting a river. If plant A produces a predetermined maximum amount of pollutant twice as fast as plant B, and together they produce the maximum pollutant in 26 hours, how long will it take plant B alone? Alright, we can set it up the same way as before. We could do the rate times the time. Remember, the amount from pollutant A would be the rate of pollutant A times the time, plus the rate of plant B times the time, that equals 1. So the rate of pollutant A, we already had it up there, will be 1 over x times 26. And it says pollutant B. It says pollutant A produces it twice as fast as pollutant, or pollutant A produces, or plant A produces the pollutant twice as fast as plant B. Since it's produced twice as fast with plant A, the rate for plant B would be 1 over 2x times the time, which is 26. So, if we simplify, that'd be 26 over x plus 26 over 2x. 2 goes into 26 13 times, so it'd be 13 over x equals 1. So it'd be 39 over x, add the 26 and 13, equals 1. Now this means if you multiply both sides by x, those x's cancel out, so 39 is equal to x. Alright, so it would take plant A 39 hours to produce the maximum amount of pollutant on its own. And that means it'd take plant B. Remember, it says that plant A, was twice as fast as plant B, so if plant A would take 39 hours to produce the pollutant by itself, then plant B would be 39 times 2, which is 78. Alright, here's another example of our work rates. It says, this problem appears in the 1994 movie Little Big League. It says, if Joe can paint a house in 3 hours and Sam can paint a house in 5 hours, how long does it take them to do it together? Alright, so let's start with Joe and the amount he can do. If he can paint a house in 3 hours, if he can paint a house in 3 hours, that means that he can do 1/3 of the job in the given amount of time. So, if he does 1/3 of the job in the given amount of time, it'd be 1/3 times x, which would be your amount of time. Now, if Sam can paint the same house in 5 hours, that means he can do 1/5 of the job in 1 hour. So it would be 1/5 times however much time they spend on the job painting the house. That equals 1 job. Alright, so now 1/3 times x. Remember, x is like having x over 1, so you multiply the numerator, so 1 times x is x over 3 times 1, which is 3, plus 1/5 times x. X is like having x over 1, so 1 times x is x over 5 times 1, which is 5, which equals 1. Now, if you multiply, since you have different denominators, you need to get them into a common denominator. So we need to get to a common denominator. In order to find a common denominator, we do the least common multiple of 3 and 5, which would be 15. So multiply everything by 15. And that would give you 3 goes into 15 5 times, 5 goes into 15 3 times, then you have 1 times 15 on the right hand side. So now you have, instead of 15 times x over 3, you have 5 times x, which is just 5x. Then for x over 5 times 15, that reduces to x times 3, or 3x, equals 15. So 5x plus 3x is 8x, equals 15. Which means that x would be 15 over 8 hours, which means together they would paint it in 15/8 hours, or 1 7/8 hours. Alright, the next equation we're going to go over is what we call a square root, or radical equation. Alright, so now, we're going to go over how to solve an equation. Solve a radical equation. Solve x minus square root of 15 minus 2x equals 0. I'd recommend start off by adding square root of 15 minus 2x on both sides. So after you do that, those would cancel out. So on the left hand side you'd have x equals square root of 15 minus 2x. Now since we have a square root, we would square both sides. So it'd be x squared is equal to 15 minus 2x. Because on the left hand side you just have x raised to the second power, so that'd be x squared. On the right hand side you have a square root. Remember, whenever there's no index given on a radical, we understand the index to be 2. An exponent and a radical undo each other as long as the index and the exponent are the same. So now we have x squared equals 15 minus 2x. So if we add 2x to both sides, and then also subtract 15 from both sides, you have x squared plus 2x minus 15 is equal to 0. So if we factor this down now, that'd be x plus 5 and x minus 3 is equal to 0. So this tells you that x plus 5 is equal to 0 and x minus 3 is equal to 0. That means that x is equal to negative 5 or x is equal to positive 3. That's equal. That's supposed to be an equal sign right there. So now we need to check both answers. To check the first one, remember we had x minus, so instead of x it'd be minus 5, then minus square root of 15 minus 2 times negative 5 is equal to 0. So this would be negative 15 minus, now that would be simplified to 15 minus 2 times negative 5 is negative 10. 15 minus negative 10 would be 25. We're trying to figure out if this, subtracting these would give you 0. Square root of 25 is 5. So negative 5 minus 5 is actually negative 10, which is not 0. So we don't care about that. So let's check positive 3. Instead of x minus, it'd be 3 minus square root of 15 minus 2 times 3. So that'd be 3 minus square root of 2 times 3 is 6, 15 minus 6 is 9, square root of 9 is 3, 3 minus 3 is 0, so that works. So this is our only solution, x minus 3. Alright, so now we're going to solve this radical equation. Alright, since it's equal to 0, we can start off by getting them into separate, getting them on opposite sides of the equal since it's equal to 0. If we add square or cubed root of x to both sides, alright, so if we add cubed root of x to both sides, we have cubed root of 4x squared minus 4x plus 1 is equal to cubed root of x. So now to undo a cubed root, you raise it to the third power. So you're just left with what's underneath the cubed roots. 4x squared minus 4x plus 1 equals x. So now let's get it equal to 0, because it looks like we have a quadratic, so let's go ahead and get it equal to 0. If we have positive x, we can subtract x from both sides. So those cancel out, and you're left with 4x squared, and then minus 4x minus x would be minus 5x plus 1. Now, we can factor this down, or you can do the quadratic formula. Alright. In case we didn't go over before how to factor it, when we didn't go over how to factor it, you start by multiplying the coefficients 4 and 1. 4 times 1 is 4. So now you want the factors of 4 that add to give you 5. Those factors, of course, are 1 and 4. So now we can do it'd actually probably be easier to do factor by grouping. 5x can be rewritten as negative 4x minus x, and then plus 1 equals 0. So on these first two terms, if we factor out a 4x, we're left with, instead of 4x squared, we're left with x, and if we factor 4x out of the second term, we're left with minus 1. Now for these last two terms, negative x plus 1, if we factor out a minus 1, instead of negative x, we'd have positive x. Instead of positive 1, we'd have negative 1 equals 0. So, now, if you notice, they both have an x minus 1 in common, so if you factor that out, you're left with just 4x minus 1 equals 0. That means x minus 1 is equal to 0, and 4x minus 1 is equal to 0. That means x is equal to 1, and if you solve 4x minus 1 is equal to 0, x would be 1/4. Alright, so you can check it by plugging it in, but I will tell you that they both work. Remember, you just check them by plugging them both into our original equation to make sure you get the same answer. Alright, here's another example. It's where we have two different radicals. And pretty much remember how we moved the radicals to opposite sides and you had to square it? We're going to have to do the squaring part twice, and I'll show you how. First, you do start by getting the radicals on opposite sides like what we did before. I'd recommend moving over the square root of x plus 1 because it's a negative. So, now you'd have square root of 2x plus 3 equals 1 plus square root of x plus 1. Now, since it's just the square root, you square both sides. So that'd just be 2x plus 3 equals, since we're squaring the right hand side, that'd be 1 plus square root of x plus 1 times 1 plus the square root of x plus 1. So to FOIL the right hand side now, you just do 1 times 1, which is 1, then 1 times square root of x plus 1, which is square root of x plus 1, and then FOIL the inside, so it would be 1 times square root of x plus 1 again. So you have square root of x plus 1 plus square root of x plus 1, that'd be 2 square root of x plus 1. And then square root of x plus 1 times square root of x plus 1, which would just be x plus 1, because when you multiply a square root by itself, the square root is undone. Bring down your 2x plus 3 rather. So now, if we simplify the right hand side, that would give us x plus 2 plus 2 square root of x plus 1 equals 2x plus 3. So now, if you subtract, if you get the non-square root terms on the other side, subtract positive x, subtract 2 from both sides. So, those cancel out and you're left with 2 times square root of x plus 1 equals 2x minus x is x, 3 minus 2 is 1. So now, this is the part where we have to square it again. If you square both sides to get rid of the square root now, since both sides are squared, it'd be x plus 1 squared. So it'd be x plus 1 times x plus 1 equals, now on the right hand side, since we squared 2 times x plus 1, you square everything inside the parentheses, so it'd be 2 squared, which is 4, and then square root of x plus 1 squared, which is x plus 1. So now on the left hand side, if we FOIL this, x times x is x squared, x times 1 is x, plus 1 times x, which is x. X plus x is 2x, then 1 times 1 is 1. Equals, now if we distribute, it'd be 4 times x, which is 4x, then 4 times 1, which is 4. Now, let's solve both. Let's get everything on the same side so we can have a quadratic we can factor. Subtract 4x and subtract 4 from both sides. And that would give you, it'd be x squared, and then 2x minus 4x would be minus 2x, and then 1 minus 4 would be minus 3. Equals, everything cancels out, so it'd be 0. So, to factor this down now, we need the factors of 3 that subtract to give you 2. So the only factors of 3, since it's prime, are 1 and 3. We know those subtract to give you 2. Since the second sign is minus, we know they're different signs. And since the bigger sign is negative or minus, that means we know the bigger number has the minus or the negative. That means we have x plus 1. So we have x equals, and actually not x equals, x plus 1 is equal to 0, and x minus 3 is equal to 0. That means x is equal to negative 1, or x is equal to positive 3. So now, we'll go over how to solve equations with rational exponents. For part A, x raised to the 3/5 is equal to 27. So, since we're raising x to the 3/5, we can start off by raising it to the 5/3 power. Raise both sides to the 5/3 power, because on the left-hand side, since you have x to the 3/5 raised again to the 5/3, you can multiply the exponents. Since you have a power to a power, you just multiply the exponents. That equals 27 raised to the 5/3. The 3's cancel out, the 5's cancels out, so you just have x to the first, or just x, equals 27 raised to the 5/3. Now remember, 27, if you want to factor it down, it equals to 9 times 3. 9 factors down to 3 times 3, so that's 9 times 3, and then 3 times 3 times 3, which would be 3 to the 3rd. So that would just be, instead of 27 raised to the 5/3, it'd be 3 to the 3rd, raised again to the 5/3. So now, for our value of x, since you have 3 to the 3rd raised again to the 5/3, you can multiply the exponents. The 3 and the 5/3, the 3's cancel us out, because you have a 3 on the top, another 3 on the bottom. So you're left with 3 to the 5th, which is 243. Alright, since we're raising x minus 4 to the 2/3, we can start off by raising it to the 3/2. Alright, but since we're raising it to the 3/2, the denominator is an even number, 1/2. Alright. Before we move on, I want to remind you of a rule about exponents in case you've forgotten. When you have some exponent a over b, that's like having the bth root of x raised to a power of a. So like x to the 2th, or since we're raising x to the 3/2, that's like having the square root of x and then cubing it. So if we take the 3/2 power of both sides, so if we take this 3/2 power of the right-hand side, that involves taking the square root, which means you'd have positive or negative.
feel like women tend to be more liberal.
Now, square root of 16 is 4 raised to the third equals x minus 4. That'd be x minus 4 is equal to positive or negative. 4 to the third is just 4 times 4 times 4, which would be 64. So x is equal to 4 plus or minus 64. So x is equal to 4 plus, x is equal to 4 plus 4, which is 68, or 4 minus 64, which is negative 60. Now, there are some times where we can solve an equation by putting it in the form of a quadratic. And that letter U, the reason we're using U instead of X is because we're doing substitution. I'll show you what I mean in the next couple of examples. Alright, here are a couple of examples of what I was talking about on the previous slide, where you can rewrite it as a quadratic. Let me review one of the rules of exponents. Alright. Remember, if you have a power raised to another power, you can just multiply the exponents. So like with this x plus 1 raised to the 2/3 power, that'd be x plus 1 to the 1/3 times 2 minus x plus 1 raised to the 1/3 minus 2 is equal to 0. Now, since we have two exponents being multiplied, like what we do here, we can rewrite it as x plus 1 raised to the 1/3 raised again to the second minus x plus 1 raised to the 1/3 minus 2 equals 0. Okay, so now, if we let u equal x plus 1 to the raised to the 1/3, instead of having x plus 1 to the 1/3 raised again to the second, you have u raised to the second. Instead of minus x plus 1 raised to the 1/3, you have minus u and then minus 2 equals 0. So, let's go ahead and factor this down. The factors of 2 that subtract, since the second sign is minus, factors of 2 that subtract give us 1. Well, the only factors of 2 are 2 and 1. And those two subtract to give us 1, which is our coefficient here in front of u. So it'd be u2 and u1 equals 0. Now we know they're different signs because the second sign is minus, and since the first sign is minus, that means the bigger number is subtraction. The smaller number is addition. So that means u minus 2 is equal to 0, and u plus 1 is equal to 0. Right. And that means that u is equal to 2, and u is equal to negative 1. But remember, u was just a substitution for something that was just x plus 1 raised to the 1/3 is equal to 2. And then that's x plus 1 raised to the 1/3 is equal to negative 1. Now, to get rid of that exponent, since it's to the 1/3 power, we would raise it to a power of the reciprocal. So if the exponent is 1/3, the reciprocal would be 3 over 1, or just 3, if you want to reduce it. The reason we do it by the reciprocal is because since we have a power raised to another power, we multiplied the exponents 1/3 times 3, which is just 1. So you have x plus 1 to the first, or just x plus 1. But what you do to one side, you have to do to the other. So 2 to the third is equal to 8. And now, likewise for here. What you do to one side, you have to do to the other. So 1/3 times 3 is, those cancel out, so you're left with x plus 1 to the first, or just x plus 1. Then you have negative 1 to the third. Negative 1 to the third is just negative 1 times negative 1 times negative 1, which is negative 1. So that means that you have x is equal to positive 7, and this would mean that x is equal to negative 2. Alright, again, remember you do need to check both of these. So let's go ahead and check x equals 7. Remember we had, instead of x plus 1, it'd be 7 plus 1 raised to the 2/3 power minus 7 plus 1 raised to the 1/3 power minus 2 is equal to 0. Now 7 plus 1 is 8 raised again to the 2/3 minus 7 plus 1 is 8 raised again to the 1/3 minus 2 is equal to 0. Now, if you don't have a calculator in front of you where you can just type this in, you can convert this to a radical. So, since we have a 3 on the bottom, that's like taking the 3rd root of 8. And since we have 2 on the top of the exponent, that's like squaring everything. And then, since we have the 1/3, 8 to the 1/3, that's the same as saying the cubed root of 8 minus 2 is equal to 0. Now we know the cubed root of 8 is 2, because 2 times 2 times 2 gives you 8. So that would be, we already said the cubed root of 8 is 2, so it would be 2 squared. And we're trying to see if this is equal to 0. So remember, 2 squared is 4, minus 2, and then minus 2 again is equal to 0. 4 minus 2 is 2, minus 2 is 0, so 7 works. Now we need to check x equals negative 2. Instead of x plus 1 be negative 2 plus 1 raised to the 2/3 minus negative 2 plus 1 raised to the 1/3 minus 2 is equal to 0. So, negative 2 plus 1 would be negative 1 minus negative 2 plus 1 we said would be minus 1. That'd be to the 2/3, and that would be to the 1/3, and then minus 2 is equal to 0. Now negative 1 raised to the 2/3, again, if you don't have your calculator and you want to do it by hand, that'd be the cubed root of negative 1. And since we have a 2 on top, we'd square it. And then we take the cubed root of negative 1, since we have negative 1 to the 1/3 power, then minus 2. We're seeing if it equals 0. We don't know if it equals 0 yet, so that's why I'm personally putting the question marks. So now, the cubed root of negative 1, that's just what number do you multiply by itself 3 times to get negative 1. And we know that negative 1 times negative 1 times negative 1 again gets you negative 1, so that'd be negative 1 squared, minus the cubed root of negative 1, we just said was negative 1, and then minus 2 is equal to 0. Now, negative 1 squared, since it's inside the parentheses, we would square the negative as well as the 1, so it would be 1, minus negative 1. Since we're subtracting a negative, they both turn to addition, so it would be 1 plus 1, and then minus 2 is equal to 0. So 1 plus 1 is 2, minus 2 is 0, so both of the solutions work. So x equals 7 and x equals negative 2, they both work. So now we got part B. Let's go ahead and get that positive 2 on the same side by subtracting 2, so you'd have 6x to the negative second plus x to the negative first minus 2 is equal to 0. And remember, negative 2 is this, you can rewrite it as just negative 1 times 2 plus x to the negative first minus 2 is equal to 0. Now since you have x raised to the power of negative 1 times 2, you can rewrite it as x to the negative first raised again to the second times 6 plus x to the negative first minus 2 is equal to 0. Now we can do our substitution. Let u equal Since they both have an x to the negative first, if we let u equal x to the negative first, that would give us 6u squared plus u minus 2 is equal to 0. Now, let's go ahead and do factor by grouping. We know, in case you've forgotten, we multiplied the leading coefficient and the constant together, so 6 times 2 is 12. We want the factors of 12 that subtract to give us this coefficient, which is 1. Those factors that subtract are 4 and 3. So, we rewrite this u term plus u as plus 4u, and then minus 3u, then minus 2, and then write your 6u squared. Now you look at the first two terms, you see what you can factor out. 6 and 4 are both even numbers, so they're both divisible by 2, so you can factor out a 2 and also a u. So that leaves you with 3u, because 6 divided by 2 is 3, u squared divided by u is u, plus 4u divided by 2u is 2. Now you look at these last two terms, minus 3u and minus 2. You could factor out, since they're both negative, you could factor out a minus 1, and that would turn them both into positive. Negative 3 divided by negative 1 is positive 3u, then minus 2 divided by minus 1 would be plus 2, or positive 2. Since they both have a 3u plus 2 in common, you can factor that out, so it would be 3u plus 2. And what we're left with is 2u minus 1 equals 0. So that means 3u plus 2 is equal to 0, or 2u minus 1 is equal to 0. So that means if we solve this one for u, we'd have 3u is equal to negative 2, and u is equal to negative 2/3. And for this equation on the right, that means that 2u is equal to positive 1, and u is equal to positive 1/2. Now, remember, u is equal to x to the negative first, so it'd be x to the negative first, raised again, or x to the negative first is equal to negative 2/3, and x to the negative first is equal to 1/2. Now, there are two different ways you could go about it. You could raise everything to a power of negative 1. Because remember, negative 1, if you want to rewrite it as a fraction, you could do negative 1 over 1. So the reciprocal would just be 1 over negative 1, which is just negative 1 again. So negative 1 is its own reciprocal. So for this, x would be 1 over negative 2/3. But remember, when you're dividing by a fraction, you flip it and multiply. Since we're dividing by negative 2/3, you flip it. So it'd be 1 times negative 3/2, which would be negative 3/2. So that's our first possible answer, which we still have to check. Likewise, over here, if you raise everything to a power of negative 1, x is equal to 1/2 to the negative first, or 1 over 1/2. Which is just 1 times 2 over 1, which is just 2. Remember, you have to check, I would recommend whenever you're solving these for your homework, check both solutions you get. I will tell you, just to save some time, that if you plug these in and do the algebra correctly, they will both work. But if you're confused about checking it, you can always ask me during class. Or send me an email or a text message or something. So here's an example. Solve the fourth root of x squared plus 6x is equal to 2. Okay, since it's the fourth root, you raise both sides to a power of 4 to get rid of the radical. So you're left with x squared plus 6x is equal to 2 to the fourth, which would be 16. So now if you get this to the other side, you have x squared plus 6x minus 16 is equal to 0. So if we factor this down, we're looking for the factors of 16 that subtract to give us 6. We know those factors are 8 and 2. We know they're different signs because the second sign is subtraction. And since the first sign is addition, that means the bigger number goes with addition. So that means x plus 8 is equal to 0, and x minus 2 is equal to 0. So that means x is equal to negative 8, and x is equal to positive 2. So now remember, we need to check both answers by plugging it back into our original equation. So if we check x is equal to negative 8, we have to do the fourth root of, instead of x squared, it'd be negative 8 squared plus 2 times negative 8. Instead of plus 2 times x, and see if that equals 2. So remember, negative 8 squared is 64, and 2 times 8 is negative 16, equals 2. Oh wait, that should be 6, not 2. So that'd be 48. So 64 plus negative 48 would be 16. So in the fourth root of 16, if you type in your calculator, is 2. So negative 8 works for a value of x. Now let's check negative 2. So if we do the fourth root of, instead of x squared being negative 2 squared, plus 6 times negative 2, see if that equals 2. Negative 2 squared is positive 4. 6 times negative 2 would be negative 12. 4 minus 12 is negative 8, which does not equal 2. Because since we're taking an even root of a negative number, you'd end up with an I, with a complex number or an imaginary number. So negative 2 does not work. So the only solution that works would be negative 8. So here's another example. It's one of those rate and time problems that we were doing earlier. It says, a sewage treatment plant has 2 inlet pipes to its settling pond. One pipe can fill the pond 3 times as fast as the other pipe, and together they can fill the pond in 12 hours. How long will it take the faster pipe to fill the pond alone? Okay, now remember, if it's working on a particular job, the amount done is equal to the one job over the time. The amount done over for a given time interval is equal to the job, the amount of job done, which in this case is 1, over a given time interval. So the faster pipe, we could just say, is 1 over t. And then remember to solve for that 1. For it to be equal to 1, it'd be 1 over t times the amount, which is 1 over t, times the time, which is 12, plus the slower pipe is 1/3 the speed, so it'd be 1 over 3t times 12. That equals 1. Now 1 over t times 12 is just 12 over t. Then 1 over 3t times 12 would be 12 times 1 is just 12. So that'd be 12 over 3t equals 1. Now 12 over 3, that reduces to just 4 over 1, so it ended up just being 4 over t. Now 12 over t plus 4 over t, since they have the same denominator, you can just add the numerator, so it'd be 16 over t is equal to 1. So since 16 over t is equal to 1, you multiply by t. So 1 times t is t equals 16. So the faster pipe can get it done in 16 hours.